Unit 6, Lesson 10. Using data displays to find association. For a survey, students in a class answered the questions, do you play sports? Do you play a musical instrument? So if we look at the top one, so if they play sports and also play an instrument, there's 5 out of the total of 16. So this number plus this number should equal 16. Well, that means this has to be 11, because this plus this equals this, because this is our total. Total means to add. The next one we can't do anything with yet, but we do know if you're going down, this number plus this number will equal this. So 11 plus 4 equals 15. We also know that this number plus this number equals 25. So that means this is 9. Well, now we figure out this plus this. 5 plus 4 equals 9. When we're going this way, it means this is 5, and that means that is 10. Because each column or row, when you add either all going down or going across, it will need to equal. So we have 5 plus 11 is 16. We have 4 plus 5 is 9. 5 plus 5 is 10. 4 plus 11 is 15. 16 plus 9 is 25. 10 plus 5 is 20. 10 plus 15 is 25. So to the nearest percentage point, what percent of students who play a sport don't play an instrument? So we have a total of 16 that play sports and that don't play an instrument. So 11 out of 16. 11 don't play an instrument out of 16 students. To find percent, we need to divide. So we have 11 divided by 16. We get 0.6875. Percentage, we need to multiply it by 100. So 68 3/4 are 68 75/100 don't play a musical instrument if they play sports. To the nearest percentage. So this would be 69%. Because you have to round up to the nearest percentage. To the nearest percentage point, what percentage of students who don't play a sport, so here, also don't play an instrument? So we have 4 out of the 9. So 4 divided by 9, multiplied by 100 to give us our decimal. So 44% don't do sports or instruments. Your teacher will give you a two-way table with information about numbers of people in your class who play sports and musical instruments. Complete the table. To make this two-way data from earlier tables shown, complete this table to make a two-way table for the data from earlier. So we're going to use the stuff on the back. And it looks like we're using percent. So those that play sports and an instrument was 5 out of 16. And those that didn't, we already found this percent. It was 69%. So that means this one, if we're doing the same rule that when you add across, it needs to equal 100%. So we have 69 plus 21. Nope, 31. Let me double check. Clear, 69 plus 31 is 100. So this would be 31%. But don't play a sport, we answered that question. And don't play an instrument is 44%. So don't play sports, don't do instruments. 44% means this would have to be 66%. Let me double check. It might be 56. It is 56. Man, my adding is not going good today. That says 56%. It's kind of hard to see. Why don't I just do this? 56% goes right there. Mark the segmented bar graph for the table. Use 1 bar of a graph for each row of the table. So play sports and instruments was yes play, no play. And this is for instruments. So yes play, I'm going to do marks like this. No play, I'm going to leave blank. So they play sports and they play an instrument was 31%. So this is 25. Halfway between 50 and 25 would be 47. It's half 25 plus 12.5, 37. So about here's about 37. So we're going to be less than that. So yes play is probably like right here. And we said they were going to be lines. They play a sport, but they don't play an instrument is 69. So there's 50. Here's halfway would be about 62, so we're not quite halfway. And we leave it blank. So no sports and instruments is 56%. So just over halfway. And we have our lines. No sports and no instrument is just over halfway of this set because this is 37. So about here maybe would be our no sports, no instruments. Okay, complete the table from earlier using percents. So instrument or plays a sport and an instrument was 5 out of, and this time we're going down. So 50%, because 5 out of our 10 and 5 out of our 10. So this is 50% and this is 50%. Plays a sport and no instrument was 11 out of our 15. Well, 11 out of 15 would be 73%. That means the difference that we have would be 27%. Use the values from the table to make segment bars. Use 1 bar for each graph for each use 1 bar of the graph for each column of the table. Oh, I wonder if I was supposed to do one actual bar. So if we do 1 bar, let's try it. So 100%. However, if they are, so plays an instrument, so sports, we're going to say is striped. No sports is blank. So this one is 50-50. So stripes for half, no stripes for the other half. For no instrument, so doesn't play an instrument, in sports and no sports. So again, we have 100%. And we have 27%. So just above our 25 is no sport, no instrument. It might even be closer to 25 than that. And then the rest of these play sports, and this would be about 73%. Based on the two-way table and segmented bar graphs, do you think there's an association between playing sports and playing musical instruments? So that is your choice. For this one, it's 50-50, so it's hard to tell if there's an association. Not playing an instrument 73 and 27. They're more likely to play a sport, I guess, if they don't play an instrument, because it's a little bit higher. All right, next one, colored erasers. An eraser factory has 5 machines. One machine makes the eraser shapes. Then each shape goes through a red machine, blue machine, yellow machine, or green machine to have a side colored. The manager notices that an uncolored side of some erasers is flawed at the end of the process and wants to know which machine needs to be fixed. The shape machine or some of the color machines. The manager collected data on the number of flawed and unflawed erasers of each color. So here's our table. Work with a partner. Well, you're watching the video, so you're not working with a partner. You are by yourself watching the video. So we need to make a bar graph from the data table. One segmented bar graph should have a bar for each row of the table, and the other segmented bar graph should have one bar for each column of the table. So using a straight edge or just drawing the best you can, we're going to have one and the colors. So we have red, blue, yellow, green. And our numbers need to go up to at least 300, it looks like. No, because we're doing percents. So we don't need 300. We need to go up to 100. So 100. So each of our bar graphs need to go up to this anyway. So red, blue, yellow, green. So here would be 50, 75, 25, and we need to figure out percents. So of our red, which percent are unflawed? 285 out of 300. So 95%. So that means this would be 5%. And we need to create a table. What I'm going to do right here, unflawed is blank. Flawed is striped. So 95 is unflawed. So it's probably way up here. So that means flawed would be striped. Out of blue, 223 of the 240. So 93%. So a little less than this. And the rest are flawed. For yellow, 120 out of the 200. So 60%. So here's 50. 60 would be a little bit above it. And the rest would be flawed. And for green, 195 out of the 260 gives us 75%. That means the rest are flawed. The other way, the other table is flawed versus unflawed, and then each color. So I'm going to do that one right here. I'm going to do a U for unflawed and an F for flawed. And we have 100%. We need red, blue, yellow, and green. You need each of those colors. There should be boxes under your desk with colors. Share with your partner or use your own colors. So we're going to need to find some percents. So red is 285 out of the 823. So this is 35. Blue is 223 out of the 823. So 27. 120 out of 2 is 15. And 195 out of 823 is 24. Halfway is 50, 75, 25. I'm going to start with green because it's 24, so I'm going to be just below my 25. So green. And then I'm going to do my blue because 24 plus 27 is 51. So I'm going to go just above my 50 now. So I've done blue. I've done green. Now I have red and yellow. Those numbers don't add up. I wonder if let's 35 plus 27, 15 plus 24. I rounded one of them wrong. That's okay. What would this one be? 120 divided by 823. Probably because that one is at 5. 285 divided by 823. So it's because we rounded to the nearest, and sometimes you have to round up to the next number. That's okay. So we need red is 35. So right now I'm at 51. 51 plus 35 is 86. So I'm going to be kind of in the middle of 75 and 100. That would be my red. And the last one would be my yellow. For flawed, out of 177. So we have 15 out of 177, which gives us 8%. 17 out of our 177 gives us 10%. 80 gives us 45%. And 65 gives us 37%. If we add them up, 37 plus 45 plus 10 plus 8 gives us 100%. So let's do this. If we want them in the same order, we can do that. I'm going to start from the top and take the most away. So yellow is 45. So I'm not going to quite get to 50, but I'm going to be pretty close to 50. So all of this is yellow. The next one would be red, and it's only 8. So I'm going to go, right now I'm at 55. I'm going to go just below my 50. Then blue is 10. Okay, sorry. I was looking at green was 37. I'm like, no, I need to do green. But so right now I'm at 45. I need to take 8 away. So about that much. My red is just a little bit bigger. And then the rest is green. And it looks like it's about halfway. And halfway between 50 and 25 is 37. So question 2. We've made our 2 bar graphs. Are the flawed erasers associated with certain colors? If so, which colors? So flawed. Is there a color that is more flawed than others? Well, the 2 that are more flawed would be yellow or green. So, yes, yellow and green. Explain your reasoning. They have a higher percent of flaws. A higher percentage of flaws. The other ones are 10 and 8%, which flaws aren't very common. Let's see. Lesson summary. So we're looking at histograms, is what these are called. They're also called bar graphs, is what you might hear me say, or what I might be reading. So in an early lesson, we looked at data on meditation and state of mind in athletes. Is there an association between meditation and state of mind? The bar graphs show that more athletes were calm than agitated among the group that meditated. So here's the meditated one, or here's the meditated. Both of them work. You can look at it either way. But you can see on both of them, if they meditated, they are a higher percentage of them is calm compared to agitated. And those that don't meditate, a higher percentage of them are agitated than calm. So it's just finding if there's an association or something common that links them together. Like, can you tell that they are common? Number 10, practice problem. Number 1, an ecologist is studying a forest with a mixture of type of trees. Since the average tree height in the area is 40 feet, he measures the height of trees against that. He also records the type of trees and results shown in the table of the bar graph. Is there evidence of association between the two? So we have this type of tree, the percentage of them that are taller than 40 feet and under 40 feet. And then we have evergreen, under 40 feet, over 40 feet. I feel like they're pretty close to like the percentage that they have that are under and over. So is there an association between tall trees and not tall trees and types of trees? Number 2, workers at an advertising agency are interested in people's TV viewing habits. They take a survey of people in 2 cities to find the patterns in the types of shows they watch. The results are recorded in the table below, shown in a segmented bar graph. Is there evidence of different viewing habits? If so, yes, there's a difference. Chicago's watch way more comedy than Topeka, and Topeka watches more news. I wonder where Topeka is. I wonder if it's somewhere like maybe they have a lot of like weather, like extreme weather, maybe. So they watch the news more so that they can know what's going on. Whereas Chicago, maybe they don't have the severe weather, so they don't have to worry about that. So yes, there is a difference. Number 3, A scientist is interested in whether certain species of butterflies like certain types of local flowers. The scientist captures butterfly in 2 zones of different flower types and records the numbers caught. Do these data show an association between butterfly type and zone? So, we don't know any totals yet, so let's figure out some totals. So, 16 plus 34 is 50. 16 plus 24 is 40. 46 plus 34 is 80. 24 plus 46 is 70. Just so we can maybe get some percentage to see what we have. So 16 out of 50 is 32%. 34 out of 50 is 68%. Okay, let's see. 16 out of 40 is 40%. So that means this is 60%. Right now, I'm just finding all the percentages to see if maybe there's something. So this is 34, 46, 70, 66, 34 out of 80 gives us 43, so 57. Just based on all the percentages, it doesn't seem like there's a large difference in percentage of where butterflies are based on their zone. So I would say no, there's no association because we have 32% of eastern tiger swallowtails and 34 monarch butterflies are both found in zone 1, and their percentages are similar here also. So no association. Is no. I guess I didn't need to write it because you guys can write it. Association. And your reasoning is the percentages for butterflies found in each region are similar. You do have a test tomorrow. So your test questions are all about scatter plots. So let's just go through a couple practice problems. You might have a problem similar to like this. This was a lesson 1. You probably don't have these because you tear them off and turn them in. If you want to view the practice problems, you can go on to McGraw-Hill and view them. But you might have a problem like this where you have a table and you have a scatter plot. You might have to label axes. Lesson 2. You might have a problem like this where you have a table. It gives you a scatter plot and you have to say, like maybe label a point. So if there were 16 assists, how many points did they get? Unit 3 or lesson 3. Again, you might have a problem like this where it has your graph, it has your scatter plot. What are the points for player E? You might have something like this. So here's your scatter plot. Here's your line of the graph. What is the slope? Remember, when we already have our equation, it's a variable, usually y equals mx plus b or minus b, where this is your slope, this number right here. So you have to say, what does it mean? Well, our slope is points per game. So many points per 3 free throw attempts. You might have questions like this. Not which one doesn't belong, but so if we look to this, is that a good fitting line? Is that the best fit line? Is it a linear line or nonlinear? Is it positive or negative? What type of association goes with it? So you might have to determine if something's a good fit. If it is, then good. If it's not, then find a new one. You might have a question like this. Based on your best fit line, if the output is 10, what is your input? Oh, what is the output? Output, input. So if my input's 10, what's my output? 6. You might have questions like this. So based on this, which is true? As x increases, y increases. So as this is going up, our line's going up. As x increases, y is decreasing. Here's a scatter plot. Compare the hits. So describe the relationship. Is it linear? Is it positive? Is it negative? Is it nonlinear? Is there no association? Questions about a table based on the line, based on your points. There might be questions about circle any clusters, or are there clusters? Remember, this is a cluster and this is a cluster. It's where you have a bunch of data points stuck together. Which one shows the better fit line? A or B? You might have questions like this. Select all. So we don't have a straight line because if we follow the points, it curves. So is it linear? Is it nonlinear? Is it overall positive or is it overall negative? Is there no association? So that means you have dots everywhere or points everywhere. That will be the gist of your test, or like questions like this. Is it positive, negative, no association, or zero slope? That will be your test for Friday. If you have questions, email your teacher. We would be happy to help you.